class and it seems to go okay. You get home and it's like, okay, I forgot what I was doing. So give me again just another day or so, and usually, like I said, it keeps getting a little bit better. But today, as we work through our notes here in just a minute, we're going to just, like I said, do the same big idea. We're now going to throw an extra thing in there. Nothing major, but we just keep tweaking it each day. So from last night, let's throw out any questions that you may have here. All right, anybody got any questions from last night? You just couldn't see the combination that you're getting there. Yeah, obviously the answers are there, but just trying to walk through that. Anybody have any particular questions? This is your time to ask. Yes, ma'am.
Number 6.
6. All right, let's go find 6 here. All right, we do our questions. All right, we're in standard form. Next thing is identify that A, B, and what is B? -7 and C. All right, as we saw yesterday, we tried to figure out how to kind of undo the multiplication. We saw that the A and the C is always being created by multiplication. The linear term is being created by multiplication and addition. So that's why I always tell you, list out the factors of A and C. So how do you get a 1? Yeah, 1 and 1. The only way you get a 1 is 1 and 1. How do you get a 10? Yep, and there are, again, 2 possibilities, okay? So I count for both of those, even though there are only 2 there. And then before, again, start making my guesses, I want to look at that 10 again, realize it's positive, and what is the only way to get positive through multiplication? Either, so they got to be the same sign. And of those 2, I can go back and look at that polynomial and realize it's got a negative in there. So what does it imply? I get to choose the right. Now, the A right here starts to build our 2 quantities. This one's nice because it has 2 minuses, so you don't have to worry about where does the plus go and where does the negative go. That you do, but here, not. And then lastly, finding that combination, okay? Keeping in mind, what is our goal? Our goal is to get a -7 through addition. So this is one where you can kind of fall into it, okay? The only combination that works to get a 7, you should see the 2 and 5 should jump right out at you. We always check the guess, and as I told you yesterday, x squared better come out the same. It always does. -5x right here, and these are the 2 terms that build that linear. That's where I'm checking to see if I'm on the right track or not. It is. And the last term, I can check it, don't have to, because if that linear term works, you are good to go. So that's where I'm getting the x minus 2 and x minus 5. As I said yesterday too, does the order of the quantities matter? No. What's inside the quantities better be exactly the same. All right. Anything else anybody's got? This is your time.
I'm just, so like on number 7 and number 8, I'm kind of just confused on like what.
So staring you in the face. Those are 2 quantities that are exactly the same, right? So that is that idea from 2 days ago. That's GCF right now. Now, when we did that problem a couple of days ago, I asked what was some of your guys' plan of attack, and most common thing is to say, hey, I'm going to distribute combined like terms in standard form, and then I'm going to factor. And you more than can definitely do that, but that's the long way. This is a shortcut. You've got the same 2 quantities, and because of the exact same 2 quantities, that's a GCF. So I'm taking out an x minus 1 from here, and I'm taking the x minus 1 from here, being left with a -4. So if you want to go through and distribute and do like what we did yesterday, identify A, B, and C, factors of A and C, you definitely can. But that's just a longer route. It'll work, just take you a lot longer. William?
I just have a question about number 4. Is that meaning that it's like, I mean 9, sorry, you were right.
No problem, you're fine.
There's 4s in it, sorry. That just means it's twice, right? Because I wrote it out, I didn't write it.
No, so let's go ahead and talk about number 9. It's a nice one to talk about. So it's very similar to what we talked about the add-on, where we're in standard form, we're doing out our factors, and you don't know, because I haven't talked about it, all right, but this is a special trinomial. It's a special one. We don't change anything that we do with it. But at the very end, I know it becomes special because we get the same two quantities. So A turns out to be 1 and 1 again. B is several possibilities. All right. And what do we know about 16? It's positive, so both signs in this case have to be negative. So as Lillian was saying here, she did all her factoring, she got the negatives, and we're trying to get an 8 out of here. This is one you don't really have to think too much about because it's an 8 and you see those 4s. And the reason why, again, that is the case is because A is 1. You might have noticed when A is 1, it's a lot more quick than, say, when A is, I don't know, a 5 or a 3 or a 7. There is a reason for that, but who cares? All right, you got the hard stuff going down. This answer's fine, okay? But as we've talked throughout this school year about reviewing some of your exponent properties and all that, when you get the exact same two quantities right here, typically what we do then is rewrite it as the quantity squared. Are you wrong? No. I would take that answer. But get into that habit because as we get into the second semester, we're going to look at one of the other methods we call completing the square. And that right there ties into that. You're talking about completing the square, I think, right now, aren't you?
I think we're about to
start today, and you're going to see this dude right here. It's called a perfect square trinomial, and you're going to see that a lot where you can get the exact same two quantities squared, so it's going to tie into something down the road. Okay, so you can tell Mrs. Dresden, you can teach a lesson on that. All right. Anything else anybody's got? Good question there. All right, the usual. If you just have half that completed, don't turn it to me half completed. Get it to me on Monday, all right? Work out this weekend. Make sure your name's on it, throw in the basket. Let's get out those notes. Let's go to day 2 of factoring. All right. Again, just need a pencil. Don't really, you might want to calculate out. Might need a calculator. Numbers might get a little large. I can't remember on that. Okay, might need a calculator. Now, yesterday, the polynomials that I gave you, they were very specific ones. So when I designed this these lessons here, I arranged it such that we did about 60%, 70% of the topic yesterday. And now today we're just going to tweak it a little bit more each day. The ones that I gave you are the ones that are, if you can do these, you're on the right track. If you go back to yesterday's notes, you don't have to, okay? When we identified the A, what was A right here? A is 5, A is 7, A is 11, A is 3, A is 13. I gave you some as well where A is 1, A is 2. Those are all very specific numbers. Anybody remember? Anybody know what those specific numbers are? Those are primes. Well, what do we get with primes? How do you create a prime number?
It's itself times 1.
Yeah, it's 1 in itself, exactly. So what we're going to start kind of tweaking here today and tomorrow, or not tomorrow, but Monday, is going from prime to something else, where that's where, again, you might get the next level of frustration at, okay? But today, we're going to try to look at some big ideas to make those numbers not as crappy. Sometimes we can do it, sometimes we can't, and we're just stuck with crappy numbers. But I gave you very specific ones that first day to start off with. So, let's see. I think I skipped over. Yep, right here. So let's go ahead and just start off. Quick review from yesterday. Let's take letter A right there. Okay, this is one we did yesterday. Is it in standard form? Definitely is. Identify me. A is 7, B is -3, and C is what? -10. Factors of A, factors of C. Again, I kind of up here obviously working, but you should be kind of working ahead, checking my work as well. Okay. We do factors of A, factors of C, factors of 7 are 1 and 7, 10. And then before I start making my guesses, I look back at that C. It's a negative. And what do I got to keep in mind with that negative? What's got to be true about my signs? Yep, you gotta have one of each. They gotta be opposites. Now, where the opposites go, I don't know. All right, that's part of my guessing. I'm trying to figure out. There is definitely a pattern there, but I don't ever tell you that. You either figure out on your own, or who cares? You still can do it. Okay. So the 7 starts to build it. What are we doing? Okay. A 7K and 1K start to build it. And this is again where we were at from yesterday. It's all about the practice. Give you a second to chew on that. You're using a positive and negative, where that plus and minus goes, I don't know. And then what are you going to use? 1 and 10 or 2 and 5? Okay. And what's my goal? We're trying to get a negative 3 out of that. So I'm going to give you a second to kind of try that on your own. And you always know that you can get there, because when you check your guess, if it doesn't go back to the original, then your guess was not right. Try it again. Maybe you're close. Maybe just change the signs. That's where you kind of again keep working and plowing through and trying out. So now first readers there. All right, who's else? Caleb's up. Max. Andrew's still on. All right, as you're plowing through there, trying to figure out a negative 3, I would probably not spend my time on which pair. 2 and 5, I don't think it's working for you. Okay. I believe it should be 1 and 10 somehow. So figure out the 1 and the 10 off of there. And then where's the 1 go? Where's the 10 go? Where's the plus go? Where's the minus go? That's what you're figuring out. Again, it's just like a puzzle. That piece doesn't fit there. Looks like it, but it doesn't fit there. Go someplace else. That's again what you're trying to figure out. So I have a suggestion here, 7K what, Alex?
Minus 10.
And then have to have a plus 1. So let's check her guess. Alright, as she suggested that, I saw some heads shaking at the same time. So as we do that right there, 7K squared, that makes sense. 7K is what I'm now looking at with these two linear terms. And right there I can stop. 7K and negative 10K combines to give me negative 3. Cool. Alright. Let's do another one here. I got a bunch of extra ones here for today. On this side, next side's really what I get to. So on this side, let's go down one. Let's do letter C, please. Okay, I'm going to just kind of jump around on this page. Now, I threw this already in yesterday. You had some practice on it last night. I've done it for enough years. We forget about the GCF. Okay, that's usually what students want to do. We're focusing on this A, B, and C. But what should jump out to you is we are missing which of those terms. We're missing we're missing the C, aren't we? And when C is 0, you just got to kind of trigger yourself to realize I got to focus on the GCF. Ignore everything we've been talking about. Do the GCF from a couple days ago. So GCF here, walk it back through. 3 and 2. Anything for 3 and 2? No. N squared and N. Anything for that? I can take out what? N. Yep, show me a little life here. So I can take out an N. I'm doing the GCF. And what is doing the GCF? I'm doing multiplication with division. So show me what you have left over. What do we have left over? 3n minus 2. Stop. You're good. All right. The GCF you always have to do when C is 0. Okay. All right. Let's do anything else special on this side. Let's just go drop it. Let's do letter E, and then we'll flip it to where today's at. Okay. On letter E, we in standard. Yep, pretty cool. A is 1, P is what? 3, and C is negative 40. Bless you. Here, A is 1. So factors of 1 are still 1 and 1, right? 40's got several. Again, the 10 seconds it takes you to write down those pairs of factors, I would always encourage you to do that in numerical order. 140, what? 220, 3 no, 4 and 10, 5 and 8, and once you get to that kind of repeating point, stop listening out. You already did. And before I start making my guesses, I gotta go back to that -40 and think about the signs. What's gotta be true about the signs for a -40? Gotta have one of each, correct. So the A starts to build it. What do we got? 1P and 1P. And now the signs and figuring out that pair. Now because A was 1, this is the easiest one as it gets. Okay? I don't ever start off with one. This because it lulls you into a false sense of security. But you should be able to knock this one out pretty quickly. What's my goal? We're trying to get a 3. And which combination gives out 3?
+8.
Yeah, a 5 and an 8. You see 5 and 8. Oh, you see a 13 or a 3 there. That 3. Sam said opposite signs. And what did we just say? A plus and a -5, right? We check out that guess. Does it matter the order of that? No. The quantities can be in different order. Just make sure whatever inside those looks exactly the same. All right. All right. Letter G is our GCF. We just talked about it a few minutes ago in our homework. It's produced right there in front of you. Okay, 7x minus 9 comes out. And what are you left with?
5x
Plus 2. Okay. So that's the old stuff now. That's a GCF. That's yesterday's work. Now let's just start slowly tweaking it. Okay. This looks exactly the same setup. Okay. It doesn't look anything like really anything different from what we did. But what happens here is when I look at that very first one though, what does jump out to you on letter A? What's that? Yeah, 4 is not prime, is it? 4 is what we say. If you're not prime, you are. Anybody? Starts with C. Ends in a posit. Composite. There we go. Good guess there. All right. And what's the other thing that jumps out to you? What about C?
much bigger.
It's a large number, isn't it? All right. When I see some large numbers up there, I am looking for GCF actually. I want to start off by reducing the size of these numbers. So let's make our life just slightly more easy. What we're going to do is look for GCF for that polynomial. And by bringing out that GCF, that 320 becomes a little bit more smaller to work with. So look across the board. This is where your calculators, again, might be handy today. What is a number that we can take out from there? Sam, you said what now? 4. So they all are even, right? So 2 is definitely going to work. But I always want to see if there's a greater number in there. 4 is a possibility. Sam checked. I know 320 works, and 72 appears to work as well. So let's go back to a couple days ago. Bring out that GCF of 4. Am I going to bring out a variable? No. Do they all have a K? Can't take away something I don't have. So the only thing I can do is bring out a 4. Now what that does for us is reduces the size of our numbers. And what do we end up with now? K squared
K squared minus 18.
minus 18K plus 80. So what we want to do now is kind of reset ourselves and focus on this A, B, and C in the quantity. A turns out to be now what? 1. B turns out to be what? -18. And C turns out to be 80. That's what you're going to factor on, okay? That's what you're going to focus on. Let's do that now. A is what we just say, 1. B is -18. And C is 80. I would rather list out factors of 1. What's factors of 1? 1 and 1, right? Now, 80 has several possibilities there. What has more than 80? 320 does, right? I'd rather go with just listing out 80 instead of 320. So I'm going to bring these sizes down. Again, this should be a fairly straightforward one, but I'm going to list them out. 1 and 80, 2 and 40, 3 no, 4 and 20, 5 and I think it should be 16, right? 6 no, 7 no, 8, and then we're repeating ourselves, right? You good, Jackson? Okay. Now on the 80, I go back to real quick. Gotta check those signs. Same signs or opposite signs? Gotta be the same. 80 is what? Positive. So they either gotta be pluses or they gotta be. And what am I gonna choose? I'm gonna choose those negatives, right? All right. Focusing on again right here. The 1K builds it. We're not doing anything different than yesterday. Signs we said have to be both negative. And what we want to fall into, we want to get into an 18. Of those pairs that are there, I would not do 1 and 80. I would not do what? 2 and 40, nor 4 and 20, nor 5 and 16. 8 and 10 should be kind of the one that jumps really out at you. And the reason why that should jump out at you is because A is 1. Okay. So what did we just say? 8 and 10. Now I always still check my guess. Now in this case, I better go back to that quantity there that I just got. Do I get a negative 18 there? Again, that is what I'm always checking. I know some of us are good guessers, but right here is where I'm looking at. I get negative 10 minus 8K. All right, so that does check out to be 18. All right, one small thing here. If you circle that as the answer, you're close, but I'm going to take off something. All right, what at the very beginning did we do, Eric?
We divided by 4.
There we go. Okay, we divide by 4. We brought out a GCF, right? So working on our notes. Okay. If you brought out that GCF, it's along for the ride. So it just keeps coming along for the ride and goes out front. Don't forget that GCF before. Because what should always happen, you should always be able to go back to the original polynomial. And if you don't have the 4 there, where do you go back to? Just right here. You should always be able to go back to the original. And bring out that GCF of 4, it comes along for the ride. Okay? Students tend to forget that. They do it at the very beginning, but then forget to write the 4. Just small things like that. Okay? Alright, let's go to the next one. Today's name of the game is blending the 2 days together. The GCF with our factoring. Alright, on the next one here. Are we in standard?
No.
Nope, let's move it around. 2p squared, what, 14p minus 36. Now when I look at these numbers, 2 is prime. Those numbers aren't bad, okay? They're not too bad to work with. But I'm now always encourage you, after you put yourself in standard, new question, is there a GCF? Is there a GCF up there? The GCF of, yep, 2. So bring that GCF out. If I take out a 2, what do I got? P squared plus 7p minus 18. Again, by bringing out that GCF, it just usually gives you even better numbers to work with. They weren't bad to start off with, but they're now even a little bit better than what we had done. Okay, so what do we have? A is 1, B is what? 7, and C is negative 18. List them out. This is old school stuff now. We've done a ton of these. Did the homework last night. We did a ton of those. Factors of 18, 1 and 18, 2 and 9, and 3 and 6. What did it just say? 2 and 9, 3 and 6. And what do I know about those signs? Sames or opposites? Yep, they gotta be opposites because it's a negative. And the only way to get a negative through multiplication is opposites. Okay? So we got everything sorted out. Let's build that polynomial. Now, as I build that polynomial right here, it's coming from that 1. And the signs with what pair is going to take you back to a 7. It's going to give you a 7 there. 2 and 9. And which one's got to get the plus? Which one's got to get the minus? The 2 gets the what? Gets the minus, and the 9 gets the plus. We always check the guess. I'm tired of doing that. P times P, it always comes out be the same, right? So as I'm up here doing my work, try to make the guesses as well. In my head, this is the multiplication I'm looking at, okay? That's the multiplication I'm looking at. I know A and C I don't have to worry about. It's that linear term, that's what I'm focused on. So as I give you time to work, that's what I'm doing up here, is trying to figure out what is the combination that works there. It's by doing that two multiplications and then adding them together. We check out, all cool, but don't forget the GCF from the very beginning. We'll say factor completely. As you can see in my directions, it says factor completely. That means bringing out that GCF and carrying along with you. All right, let's flip it. Let's do a few more here, again with the GCF. All right, next one, letter C. Again, we look at those numbers, they're relatively small numbers, but first off, have we done a 6 yet? We'll do that on Monday, okay? So what should be happening there is looking for a GCF. That is again your second step. We're in standard, look for a GCF up there. What do we have? 6, 68, and 80. What's the number that will go in there? 2? Well, anything larger? Maybe a 6? No, always check it, but the best we can do is a 2. Let's bring out that 2 then, all right? Let's make our not lives a little bit easier. And when I bring out that 2, again, this is maybe where calculators might be a little bit handy. What do we have? Divide by 2. 3r squared, 34r, and just 40. So again, we bring something down a little bit lower, a little bit more manageable to deal with, and now let's set it up. A now turns out to be what? A is 3, B is 34, and C is 40. List them out. Nothing's changed. A is 3, so A is 1 and 3. C is 40, so what do we got? 140, 220, 3 no, 410, 5 and 8. Now here, this one's not as quick. The last 2 we've done, it's been a little bit quick because A has been 1. Here, you have to account for that 3 happening. So again, as I'm sitting here waiting on you guys to maybe come up with some type of combination, all right, I'm thinking about those signs again for 40. Same signs, so what do they have to be here? Pluses or minuses? Yep. And in my head, what I'm, again, building, 3R, 1R, I'm seeing that in my head. I know the signs have to be pluses. But what I am doing for myself is this multiplication right there. And what's my goal? To get a linear term of 34, right? So I'm trying to figure out a combination that gives me that 34. So I start taking some of those pairs, and I start taking that 3 times some of those numbers up there, seeing where that gets me to, and then whatever number that goes with it for that pair, I'm bringing in right here. So that's the multiplication I'm doing in my head. I think Kale gave us a suggestion. You said 10 and 4, right? So I would go with Kale on that suggestion. Because I'm seeing a 3 here. Now if I do a 20, 3 times 20 is what? 60? Not even really close, right? 3 times 8 is what? 24? Not too bad. But is that 5 going to help me out there? Not so much. Close, but not quite. Caleb's suggestion was a 3 going with a 10 and a 4. So I'm seeing in my head that 30, that 4 has to go with it. 30 and 4, I can buy that. So that's what I'm doing in my head. It does check out. Again, you give me that answer, you circle it, you put on a blank, but I take off a partial credit because what do we forget at the very beginning? Don't forget that GCF. You should always be able to go back to the original. Okay. All right, one more here. Same deal. A little bit larger numbers. We haven't done a 15 yet. 15 is again a composite number. We're going to deal with that on Monday. But we do have ourselves a GCF hiding up there. Always look for a GCF. So GCF is what? 3. Yep, it is 3. Bring out that 3. Again, place where your calculators could be a little helpful here. 3, all right, what? 5x squared plus what? 26x. And then plus? Yeah, sorry, I was thinking 2. 24. So, reduce the size of those numbers a bit. And then A start off to be now 5 B is what? 26. And C is 24. Factors of 5. 1 and 24, 2 and 12, 3 and 8, 4 and 6. That does it. Again, I'm listing these out. Now keep in mind those signs. It's 24, right? So what's got to be true about the 24? Positives or negatives? Yep. It's got to be the same. In this case, it's got to be the pluses. And I'm paused now. Give my brain a chance to catch up with it. Give you a chance to catch up with it. Now I'm doing again in my head that same multiplication right here. That multiplication gives me that linear term. Okay. So what are we trying to get? A 26. 4 and what? 4 and 6. All right. If you're still trying to figure out that combination, Caleb suggests you maybe use a 4 and a 6. Now I've got some other, again, possibly contenders are there. But when I start bringing in the other number, that's close but not quite. So 2 and a 12. So where would you want to put that 2 at? Okay. And then 12 here, right? So 5 times 12 is 60. Plus that 2. So that 5 and 12 really kind of jumped it up. And usually once you kind of jump it up very quickly, you're now far away from that. Probably is not going to happen there. Okay. Eric?
4 and 6.
So Eric and Caleb are suggesting 4 and 6. Eric, where's that 4 got to go?
4 is multiplied by 5.
All right. So right there. So again, as I'm looking at this things here, I'm trying to figure out how to get to that 26 based off of what I just listed out. I'm just going through and doing some, hey, what's like a 5 times 3? That's 15, a plus 8. That gets me close, but doesn't give me exactly 26. I do a 5 times 12 in my head, that gets me 60, which, oh, that's pretty far away, probably not happening. A 1 and a 24, nah. And then I come back around that 4 and 6. In my head, I go 5 and 6 is 30. That's not working, but I flip it around, and that's where, yes, it does check out. Okay. And what do we have then? Don't forget the what? 3, that GCF out front. All right. That's the twist for today. Have we done anything really crazy different? No. But you have that second step now. Standard form, look for a GCF. That's that. We keep doing the same thing. Okay. That's why I said yesterday was the big day. We tweak now from there. All right, let's continue on. Yesterday, I know we skipped over it because we ran out of time, which is fine because I got some extra practices right here. All right, let's go ahead and bring in a little bit of geometry we just talked about. What I've given you here is half of a parabola, okay? I've given you the right-hand side of a parabola. So I know randomly throughout this school year so far, we've talked about the quadratic equations we were doing with square roots. Is been connected to a U-shaped graph. It's connected to a parabola. So now I'm going to bring in some of your geometry that we've been doing and talk about maybe some new vocabulary with you that are more algebra vocabulary as opposed to the geometry vocabulary. What I would like you to do then is think about, this is the exact right half of the parabola. Do your reflection and get me the same side but on the left of it. So we're going to say do a reflection. So where is this line of reflection going to be? If this is exactly the right side, it's got to be x equals, yep, x equals 2. So reflect that on over. Okay. So I gave you the exact right hand side of the parabola. I want to get the left hand side. So let's take some nice points. I've got a nice point here at 3, 0. That's 1 away. We're right here. I got another nice point down here at 4, negative 3. I reflect it over. It's 1, 2, 1, 2. All right, that's nice points. All I've got is just those 2. So now do your best to make that graph and kind of view it out. All right, make it look U-shaped. Don't make it look V-shaped. V-shaped is something else. That's absolute value. My sophomores should know that for sure from last year. Okay, that is U-shaped. So what we're going to do here is start trying to make some connections with what we've been doing and talking about, and then second semester as well. All right, let's bring in some vocabulary. Because of our time, we've been talking about some intercepts, but we've been talking about the y-intercept. Here, though, I'm asking what are the x-intercepts. So let's see what you have done over the last couple years before me. Anybody? Can they quickly tell me what are my x-intercepts here? Yeah, well, 1 and 3. My sophomores should be just like that because I know we hit you on that last year. It's where it's crossing the x-axis at. So it's crossing the x-axis here at 1, 0 and 3, 0. What do we say for the y-intercept? The y-intercept always occurs on the y-axis, and it's at 0, something. So the x-intercepts always occur on the x-axis. That's what we call the x-intercepts. And then it's always going to occur at something, 0. And for the parabola, how many do we get? We get ourselves 2 of them, right? And we're going to modify that second semester. We can get 2 of them, we can get 1 of them, or we can get none. We'll talk about how that all kind of connects in the big picture. All right, axis symmetry. We just got done talking about the last test. We call it the line of reflection. The axis symmetry is what in this case? Sam said a second ago. X equals 2. In the algebra sense, the axis symmetry is that line down the middle that is cutting it in half. That's that mirror, so we call that the axis of symmetry, which is x equals 2. Bring in some geometry. All right, another vocab word. Identifying what we call as the vertex. No, yeah, I'm hearing Caleb and Sam. I see Eric up back there. This dude right here. That's the very, very, very special and important point that everything kind of gets based off of for this parabola. We call it the vertex. Everything happens around the vertex. So that is what we call the vertex there. Actually, I should have wrote the word vertex instead of 2-1. You know what that is. Everything happens at the vertex. It's a very special point on that graph. And that gets classified as one of 2 things. That vertex gets classified either a maximum or a minimum. If you've never ever heard this before, do not overthink what you think the answer is. When I look at that parabola, do you think that vertex will be classified as a maximum or a minimum? Yeah, why are you thinking a maximum? Because it's the highest point on that parabola, right? Go with that kind of basic idea there. This is what we call as the maximum. Now, I ask you, then the follow-up question always is, well, what's the value of that maximum? That is the highest y value on that graph, or the lowest y value on the graph. And the highest y value then is, it's always the y coordinate of the vertex. So we say correct. Y is 1. Okay. That is always my either highest y value or lowest y value on that graph. Now, right below that, I got a couple other questions I see. Oh, one more question. Where is the y-intercept located? Yep, right here is my y-intercept. And we say 0, what? -3. So what we've done here is the process of slowly analyzing a parabola. One of our backfill things that we'll continue to do second semester, that is an Algebra 1 skill, is analyzing graphs. And we've done a little bit of it throughout the school year by what's the slope, what's the y-intercept, does it increase or decrease? Now I'm adding on a few new things with parabolas. Okay. If I go back to this one, actually let's just see what the last one does for us. Go plot those 4 points. What type of shape we get on those 4 points? Negative, what do we got? 3, -1. -4, 0. And -2, 0. And 0, 8. There's a typo there.
Okay, cool.
Yeah.
I was very confused.
Nope. Just go and scratch it because we should be getting a parabola. This -2 looks like, I'm not sure which point got jacked up. So we'll just have to scratch that, dude. Yeah. My follow-up question was gonna be, right here a second ago, we said it's a maximum. How would I have gotten a minimum? What would that graph need to look like in order to get a minimum? Yep. Opening up. This is what we say is opening down. In order to get a minimum, we would have had to have the graph open up, and the vertex would have been classified as that. Okay. All right. Obviously, we'll pause.